Now let's go back to our relationship of two tori. One of the fields, magnetic field, is pointing clockwise, the other one is pointing counterclockwise, and that yellow arrow, that's a ray of a longitudinal electric field ray, and it happens to come exactly between where the two tori meet. That causes a fusion of the tori together. One of these directions is expansive. The other of these directions is contractive. That's your yin and yang. And where the fusion happens is an area that now takes on a property that's in certain ways similar to a black hole. It's called the 0 point. And the 0 point has special properties. So when we shake the remedy and make these bubbles, and the bubbles collapse, the small ones, and cavitate, and cause this ray of an electric field, longitudinal electric field, and they come right in between, they do the fusion, and the fusion causes a plasmoid. The plasmoid is balance because it has the yin and it has the yang. And the place where the two come together is the place of this 0 point. Things that are balanced have different properties from things that are not balanced. And what we're going to talk about now, we'll get into, is what's going on in the thunderstorm generator. So I think we've said this. So here's our picture. Hand drawn. Two tori. You see they're going around in different directions, the fields. You see the A field, one going up and the other going down. Tell me what happens right in between these two lines. This one's going up, this one is going down. When they meet in the middle, 0 A field, they cancel each other out. If there's 0 A field, tell me about the magnetic the energy carrying magnetic field. That's equal to the curl of the A field. And if the A field is 0, the curl of the A field is 0. So this is a place where there's no magnetic field. Satan, they're here. You see here the electrons, they're moving around. This one is going from the inside to the outside. This one is going from the outside to the inside. That's the sheet of electrons. But what happens when the B field is 0? So the generalization of Maxwell's equations explains that when the B field is 0, the kind of waveform that exists is a longitudinal wave in that area, in that volume. Longitudinal wave means it's going back and forth along the direction of propagation. And when that happens, in that area where the B field is 0, there's a scalar field. Now, if you've listened to let's say the new kinds of things that people are talking about when they talk about scalar fields. Unfortunately, some of the people who talk about scalar fields didn't even know the definition of a scalar field. A scalar field means every point in space in which it exists has a number associated. It's not a vector. The temperature of this room at any point in the room You put all of those temperatures together and order them. That's a scalar field. So there's a scalar field that exists in this little green elliptical shaped region. It's a field. A field is not just a number. It carries a unit. Temperature carries the unit of temperature. The unit in this field is exactly the same units by which energy magnetic fields have units. The modern unit is the Tesla. The old unit is lepers per meter squared. So we have in here magnetic field, energy, but not as a vector field, which has a direction, just as a scalar field. Different properties. And now we go back to this image. When I was talking about this image before, I didn't talk about the spherical shape. I just said it's like a sketch in a comic book. You know what this is? We're looking at the cross section of a torus. We just sliced it and perpendicular to the plane of the torus. And this is the core that has no ions. This is the annulus region around the ring that we talked about before. That's what's going on. And now we come to the thunderstorm generator. You can see here there's an engine. It's mounted in a frame. The engine. And this part of the engine is actually the generator. We'll start from here. Air comes in here, it encounters a ultraviolet lamp. You put water in here, and the water is traveling from the bottom here to the bottom here. And this is at a higher elevation, so the water begins to build up as the water is poured in here. Eventually, the air will be pulled through the water and make bubbles coming up. And this material over here is a lot of stainless steel tiny strips, almost like the kind of thing that you would use nowadays. It's typically plastic to clean a pot. So the bubbles come up from the air here, and they go through here, which chop the bubble in half and chop the bubble in half again and again and again until it gets to a very small size. And then the air comes up through here and into this section of two spheres. If I were talking to an automotive engineer and started to explain, yeah, look, there are two spheres. Actually, this is a sphere within a sphere within a sphere, 3 levels, like the Russian dolls. And this tube over here is a tube within a tube. And the air bubbles come up around here. And what did I say happen when you have bubbles? And when the bubbles cavitate, what happens? You get that little spark of energy. And the water is carrying the coherence domains. And the coherence domains form stacks. They meet each other left, right. And the longitudinal wave fuses together two tori of neighboring coherence domains. And that forms the plasmoids. So as we're going up in the bubble, from the bubbler, the plasmoids are coming up. And then they have their part. They're in the part between the central sphere and the inner sphere. and they are rotating around in a clockwise direction. And then they go up, rotate again in this sphere in the same kind of configuration in a clockwise direction, come out, go up and around over here, and go into the carburetor. Here is the exhaust. It comes out into the sphere and goes counterclockwise between the middle sphere and the outer sphere. And in here, something happens. Transmutations. Things that are not in the air. Elements that are not in the air and not in the fuel begin to form in here. Then it goes down here, going the same anti-clockwise direction, and comes out. This is the end of the exhaust. Now, what's very special about this configuration, which everybody looks at, knows all about automobile engines, would say, that's not going to do anything. I think I covered this. When you look at the exhaust, what do you expect to find? You're burning a hydrocarbon. So the oxygen from the air links onto the carbons and form carbon dioxide, and the oxygen of the air links onto the hydrogen from the hydrocarbon and forms water. So we have oxygen tied up in the carbon dioxide, tied up in the water. But what we find when we look at the gases is that it's low carbon, maybe in the 1% area, carbon dioxide. 1% rather than 10%. Low nitrogen oxides, which typically are around 1%, they disappear. Low hydrocarbons, also typically in the 1% area, disappear. And a high oxygen. High oxygen with a properly constructed arrangement, meaning no leaks. It could be 19–20% oxygen. That's unheard of. I could breathe the exhaust. What happens when somebody tries to breathe the exhaust of an automobile engine? Take your engine, put it next to the window in the bedroom. What's going to happen? The carbon dioxide and the carbon monoxide are going to come in through the window, and the person sleeping in the bed is going to die. And that happens. I don't know what the statistics are, but it's in the tens of thousands of people each year in the United States. So the question is, how does that happen? It's unbelievable. I can't look at that in any mechanical way. I can't look at that in any chemical way to say what's going on. And if you start to think about it, well, if there was high carbon before and there's low carbon now, and there was almost no oxygen before, and now we have some oxygen, you might think that the carbon transmutes to the oxygen. Actually, that's what I thought. Something else is going on. When we take a look at what's inside the spheres on the surfaces, we find there are residues on the surface. What kind of residues? Residues of elements, tied up chemically various ways, which are not present in the fuel or the air. And now we're going to take a look at some of these. I think I've actually said everything here. We're going to take a look at a Caterpillar engine that's tied up with its generator, 400 kVA. The engine had about 500 hours of operation over a few-year period. The engine would turn on when the demand of the electricity on the transmission lines was getting too high, and so it would turn on to give the transmission lines some additional energy. Otherwise, the electricity would have to be cut off. The sphere sizes were 18 inches, 24 inches, 18 inches, and 12 inches. And what ratio is that? 24 to 18 to 12. Divide by 6. 4 to 3 to 2. You see, it didn't make a difference, the absolute size. What only made the difference was the ratios. In 2024, in the area of March of 2024, Malcolm had the spheres disassembled, cut into pieces. Most of the pieces were about 2 inches by 2 inches. These pieces were given to Bob Grenier of the Martin Fleischmann Memorial Project to examine. Grenier talks tomorrow, by the way, here. Malcolm paid for his transportation to get from the European country he was in to scanning electron microscope. I think it was in California, maybe. The analysis of those residues by the scanning electron microscope, which had an energy dispersive spectroscopy system, which means if you mark, this is the place I want to look, you place the electron beam there, at a point, at a circle, among a line segment, however you want to do it. The energy dispersive spectroscopy system looks at the scatter of energy from where the electron beam was pointing and tells you the elements present. It could be something with an oxide, could be something with a sulfate. Tells you the presence of the element, not the chemical formula, but the presence of the elements. How much of each. And that system was showing the presence of carbon, oxygen, and nitrogen. Good, that's clear. Silicon? Sulfur? Or maybe you can say that this was a gas-driven thing, a natural gas. Maybe you say some of the sulfur came from a natural gas. Fine. Calcium. Sodium. Aluminum? Really? Chlorine? Zinc? Magnesium? Titanium? Chromium? Iron? Well, the iron, you can say it's stainless steel. It's coming from the steel. Nickel? And there are others yet. That's a difficulty. Elements that were not present in the air and the fuel show up in the residue. How is that possible? It's not a chemical reaction. It's a transmutation. Here's a little bit of the proof. We have 50, 60 images of this kind. This shows a 29 micron field view. From the left side to the right side is 29 microns. A micron is a millionth of a meter. And you see, carbon, nitrogen, oxygen, yes, aluminum, sulfur, chromium, iron, and nickel here. And to these concentrations. High concentrations of oxygen, which means we have an oxidation going on. But these other elements, aluminum, chromium, nickel, what about them? That's one. Here's another. This is an example of a crenulated sphere. The top of the sphere has broken off, and what remains is this piece here. And so we have Something form on the outside and something is on the inside. In this case, we're looking at the top, right here, this region. Yes, carbon, nitrogen, oxygen, you see that all the time. Aluminum, silicon, sulfur, calcium, chromium, iron, and the outlier is promethium. And the last one I'll show is this one here. This one is interesting. Start off from here. You see, it's a tubular kind of thing, and then it has a bulb of something here. The tubular kind of thing is a little bit translucent. To another one, 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 and then here. What's going on here? It's a string of pearls with carbon. And they're spaced that way because there must have been a standing wave. And that carbon is not ordinary carbon. That carbon is diamond. We're going to try to make a hypothesis of how it's possible for these observations to have taken place. To be simple, we will assume an ideal complete burn. That means there's no carbon monoxides. There are no nitrogen oxides. The input to the engine is fuel, air, which is composed of nitrogen, oxygen. The next one after oxygen, I believe, is something, a small amount, around 1% of argon. And the air is carrying humidity. It's carrying water. Most humidities are 50% or higher. Unless you're in this region here, which is a desert. And then you get lower. What's going on with the spheres is where we have a coherent resonant energy with the plasmoids. They disassociate the CO2 into carbon and oxygen and the H2O of hydrogen and oxygen. The CO2 is more of a complete disassociation. The H2O is partial. The hydrogens fuse to make helium. Some carbons are put into a fission process to make helium. 3 heliums make a carbon. Each carbon fuses with 2 heliums, make a neon. So the output is oxygen, nitrogen, and neon. Where did the oxygens come from? When I disassociate the CO2 and the H2O. I'm essentially recovering the oxygens that were part of the oxygens in the air that was coming into the carburetor. The carbons, we could fuse the carbon with a helium. It would make an oxygen. If that what was going on when I measured the presence of how much, or computed I should say, how much oxygen we would have like 30% oxygen. Someplace much higher than 20%. So that can't be because it doesn't fit the measurements. Neon. Well, if I take an exhaust analyzer made for automobiles and I put it in the exhaust pipe of a car or of a combustion engine of any kind, I'll measure the oxygen, I'll measure the nitrogen, I'll measure the carbon dioxide, I'll measure the CO2, I'll measure the nitrogen oxides. I will not measure the neon. So this hypothesis, which I have, is testable. You just get a general gas emissions kind of instrument that it picks up the presence of neon. If the presence of neon is there, then we have something that's consistent with the hypothesis. Is there's no neon there, we have to go back to the beginning and figure something out. There are multiple pathways. I just talked about one. What about the residue of the elements in the spheres? Where do they come from? So there's a process. This depicts the alpha ladder process. This is the process that happens in stars after they have burned, if you will, or fused all their hydrogen. Like our sun, it's producing energy by fusion of the hydrogens to make heliums. The heliums build up to the point that all of the elements, all of the atoms of hydrogen have been fused to helium, and all that's left with helium. And then the stars start a different process where they burn and fuse helium. And you go up the ladder this way. This is the alpha ladder, and this is the what Malcolm calls the omega side, the odd numbers one. And each of these fusion processes, when you do the fusion, you are increasing the energy. You generate additional energy as heat, for example, as light, for example. And this is what comes out from the stars. So this is interesting because this explains what is going on with the residues, what is going on with the residues of the... Now, if we want to look closer at the different reactions, this is the reactions involving hydrogen. A hydrogen within a hydrogen fused together, and it creates an isotope of hydrogen, which is called deuterium. And you can see it emits energy. For each time that happens, 1.442 million electron volts are released. The deuterium fuses with a hydrogen to make a light helium, a helium who has atomic number 2 but atomic weight 3. That helium fuses with a like helium to make ordinary helium, which has atomic weight of 4 and atomic number of 2, and it releases 2 hydrogens. So what happens, we had a process that's actually used 6 hydrogens, comes to the last place, makes the helium and releases 2. So it takes 4 hydrogens in this process to make the helium. And this is the reactions which are going on in the red giant stars. What about carbon? We have 2 kinds of reactions with carbon. There are many others, but I'm listing 2, the ones that are consistent with the hypothesis. Carbon, which has a weight of 12 and an atomic number of 6, is fissioned, and it makes 3 heliums of atomic number 4, atomic number 2, atomic weight 4. And this process is an endothermic process. It requires energy. The other process, where I'm taking a carbon and fusing it with 2 heliums to make the neon, is an exothermic process and releases energy. Notice the release of the energy more than compensates of what the energy that has to be absorbed for the fission process. We can have some oxygen helium fusion. 2 oxygen with one helium will get us to an argon, and it releases energy. So if this is one of the things that happen, we're expecting in the exhaust argon to a higher percentage than around the 1%. It's just a little less than 1% in there. That's another test that can be done. And we're coming to the end here. The instruments that we need: mass spectrometer, emission gas analyzer, not the exhaust gases analyzer, it's something more general, and a scanning electron microscope with a dispersive energy spectrometer, which gave us the concentrations. We expect to see in trace gases some hydrogens coming from the dissociation of water that have not fully fused to get to the helium stage. Heliums which have not fully fused onto the carbon. Argon, if we're actually fusing oxygen and helium together, they'll be a little greater than argon. Carbon dioxide we expect to be very small. Carbon monoxide below 1%. Nitrogen oxides below 1%. And the major gases: nitrogen, oxygen, and neon. Neon is a noble gas. It doesn't interact with anything. Never been measured by exhaust analyzers. Of course it's not measured. Who would think that a combustion engine, connected in whatever way, is something which has no electricity, just pipes, is going to make new elements and even a new gas? So this is completely testable. If the test results that we measure some neon, and we measure some argon, and we measure some helium and hydrogen, it's telling us the process we are talked about. This information would be consistent with it. But it doesn't prove that the hypothesis is true. It only says, so far we're consistent with more measurements. In science, actually, you never prove anything. Everything is a hypothesis, even that which is loss, so-called loss. All we need is one kind of observation which is not consistent with whatever we think the laws are. Science changes. That's what moves science forward. So, this is testable. We're going to be acquiring all of these instruments here, plus others. We will actually do the testing. And finally, if you're interested in the slide set, email me. The email is like my name, robert@haralick.org. And I will give you the Dropbox URL to pick up the PDF file of the slide set. Thank you, everybody, for listening.
All right, remember this is just the first part in our Alpha and Omega ladder series of interviews, lectures, and announcements that's going to be coming up during the next few weeks. So pay attention. There will be a few more videos to come. Next up, we also have, again, a follow-up interview with Robert, where we elucidate some of these ideas, talk about the things around it, and some of his personal experiences with the Thunderstorm Generator, with Malcolm, some of the developments happening in the US on the commercial and industrial and scientific side. So that's going to be really great. We also will have a lecture and an interview from the wonderful Sheila Rahman, the frequency scientist, who's a fellow student of Malcolm Bendall, who has also been elucidating on this science, and she has some of her own ideas to add in here, and this is a really fantastic lecture. We're going to be interviewing and following up with her as well. Keep an eye out for that.